Hey, Jack.
Hey, Stacy.
Hey Jack, what's the big idea today?
Dave, today's theme is design maps and detect bias. Now, so far we've created only one type of map, a simple point map with colored markers.
But there's more than one type of map, and there's 3 questions that people should always ask before they start designing a map.
First, does your data contain geographic information? Because if it doesn't, you can't create it on a map.
Second, does location really matter for your data story? Sometimes the best way to visualize your story may be with a chart rather than a map.
Third, if a map is the best way to tell your data story, then what type of map is the best match?
In this intro-level course, let's show tools and templates to create several different types of maps.
For beginners, let's start by contrasting the 2 most common types, point maps and polygon maps.
In a point map, each marker represents one specific location, such as an address, which you can represent with a different color or icon.
In a polygon map, each area represents a geographic region, which can be as big as a nation or as small as a neighborhood. Each region can be represented with different shading or coloring. The proper name is a choropleth map, but we just call them polygon maps.
Okay, so let's teach people to create a simple point map and a simple polygon map using sample data sets that we'll provide in an easy-to-learn drag-and-drop tool.
When designing polygon maps, you need to think carefully about categories and colors. So let's show everyone a helpful tool to make these decisions.
But that raises another concept that we need to teach. It's called How to Lie with Maps. It's a book written by geographer Mark Monmonier.
What do you mean? We can't lie with maps. Maps should always tell the truth.
But that's the problem, Stacy. When you dig further into map making, you begin to realize that there's more than one way to represent reality. For example, look carefully at these 2 polygon maps, which display the same data, but paint very different pictures by adjusting just the data ranges. One emphasizes uniformity, and the other emphasizes extremes.
So are you saying that both maps are equally true?
Well, what's important here is to be aware that data visualizations display the biases of the people and the software that created them.
How can we stop bias?
Well, we can't stop it, but we can teach people how to look for it and detect it and to be aware of their own. And the best way to do this is to create an exercise where we challenge students to create 2 extremely different maps using the same data, and then explain the choices they made.
In other words, teach people how to be a thief to catch a thief.
Exactly. So let's get started with the exercises and the links below.